So yesterday we talked about factoring, right? I want to show you a couple special patterns before I talk to you about solving. And I hope from the ones that you did last night, you picked up on the pattern. So the first one is called a difference. What does difference mean in math?
Subtraction.
Subtraction. Difference of two squares. Now, the box always works, always will work. You can always put it in the box, but these are shortcuts that will help you if you recognize the patterns, and they will definitely be helpful. You'll want to memorize them. All right, squares, not shapes, squares, but I'm talking about perfect squares, okay? So, x squared minus 81. This is a difference of two squares. It has to be difference. If there's an addition sign in the middle, this does not work. Okay? But if it's subtraction and they're both perfect squares, then you can factor it as the square root of this one minus the square root of this one. And then same thing with a plus sign. And I think y'all found that one we did, the x squared minus 36. Because remember, it's got to add to 0 with mixed signs. So the only way to do that is the same number, one positive, one negative. Does that make sense to everybody? Mm-hmm. Okay. No, yes, no, okay, no. Okay, let me show you another one. What if I had 4x squared minus 25? Do you recognize that they're both perfect squares? So before I throw a 0x in the middle and stick it in the box, I notice that it's subtraction, so it's a difference of two perfect squares, right? So I can take the square root of the first. What times itself twice gives you 4x squared? 2x. What times itself twice gives you 25, 5. 1 minus, 1 plus.
And you can only do that if it's minus and then 2.
Yes, and they're both perfect squares. Okay. It saves you putting the 0 in the middle and putting it in the box and going through all the steps, because perfect squares can get really big. I mean, if I had x squared, or actually let's say I had 16x squared minus 144. If you think about when you put that in the box and you multiply those two numbers together, it's going to give you a huge number, right? Mm-hmm. But knowing that they're perfect squares and I have a minus, I can just do 4x minus 12, 4x plus 12.
Well, last night we had like 1,764x squared, and it's 42 times 42. It's like for a perfect square.
Yeah. Wow. So
like,
that was, yeah, gets big. Y'all good on that pattern? Mm-hmm. All right. The other pattern definitely can be put in the box, but it's easy to well, it's not as easy to recognize, but it's a super easy pattern. It's called a perfect square trinomial. Now, you'll have to be able to recognize this when we get on to like section 6, maybe 5. I can't remember what section it is. And we start completing the square. So it's good to recognize it now. I'm going to give it to you in variable form first so that you recognize it, but then I'll do an example or two with you. All right. If you have a trinomial means 3 pieces, right? Mm-hmm. I'm thinking like ax squared plus bx plus c. If your first number is a perfect square and your last number is a perfect square, and the second sign is plus. If the second sign is plus, that tells me what?
They're both.
They're both going to be whatever the first one is, right? They're going to be the same. I'm not going to have mixed signs. All right, so the ends are perfect squares, plus sign in the second, and the middle term is twice the square root of this times this. Okay, those are the stipulations. For example, and I have, this could be plus or minus. Okay, that doesn't matter. Let me show you. X squared plus 25 So look at the equation in white. The ends are perfect squares. So I'll make you a little checklist here. Ends, perfect squares. Second sign is a plus. And if you do the square root, multiply and double, it should give you what's in the middle. Square root times, I don't want to put it like that. The product of the square root of the ends doubled. So if you have all that, then you can mentally check off that it's a perfect square trinomial. Now I told you they're a little harder to recognize, but super easy to factor. So look at the one in white here. What times itself twice gives you x squared? X. What times itself twice gives you 25? 5. If I were to multiply these two things together and double it, is that what sits in the middle? Mm-hmm. Yes. If it is, and it meets these requirements, then it factors as x, whatever that first sign was, and the square root of the end squared. Huh? Yeah, I think you did too. I think you did too. But when you put it in the box, you just got the same thing both times. Mm-hmm. But again, they get really big really fast, so it's good to be able to recognize them. Let me show you a couple examples. Some of y'all are looking at me like, that's easy, and others are like, oh my Lord. Let's see. Is it a perfect square trinomial? I heard yes. The ends are perfect squares. The second sign is plus. And in the middle, is it square, square, multiplied, and doubled? 2x times 3 is 6x, and doubled is 12x. So factored, what's the square root of this one? 2x. Take the first sign, square root of this one, squared. Now, just for confirmation, 4x squared and 9, what multiplies to 36x squared but adds to 12x? 6 and 6. GCF here? 2x, and here, and here, and here. So I get 2x. Remember, same signs. They're just both minus. 2x minus 3 minus 3, which is the same thing as 2x minus 3 squared.
The perfect square trinomial, you said you always take the first sign?
Yes. Because if the second sign is plus, they both follow the first. Right? Are y'all tracking with me? Am I going too fast? Throwing too much at you? Okay, you just got here.
It's Friday.
All right, so I won't test you just yet and make you recognize those special formulas, but they are there for you if you need them as a shortcut right now. Now, when we get to completing the square, you'll have to recognize perfect square trinomial. But let's talk about solving, because that's really what we want to talk about today. Factor and solve. So if you're keeping up, we're still in 1314. This is another day in the same two sections. If I gave you this, and I said solve that for x, what would you do?
Try to get the X on the other side.
There's two of them though.
Gotta get both of them on the other side. Or no, get a 6 on the other side.
Move the 6. So how is that going to get rid of the x's?
Then you divide by 5.
I'm kind of setting you up here because you really shouldn't know how to solve this right now. Which is the point that I wanted you to see that there's not, I mean, we have to come up with a new way to do it.
Can we just do it?
But here is what you can do.
Oh, it equals 0.
Think about this. I'm going to come back to this, leave a little space. But think about this with me for just a minute. If I have, let's say I have these two unknown values that multiply together to give me 0. Tell me what you know about one or both of those values.
One of them has to be 0.
Gotta be, that's the only way you can get 0, right? That's it. So either x has to be 0 or y has to be 0 or both. Either one of those would make the equation true. Do you agree? Mm-hmm. Okay, that's what we call the zero product property. And that's what we're going to use to solve our quadratics, because if you think about it, somebody said factor, and I didn't know if y'all were getting there or not. But when you factor, you end up with two pieces multiplied together, right? If those two pieces, I can get them set equal to 0, well, then I know that one of the two or both must equal 0. Does that make sense? It's just that it's not one single value now, it's a whole set of parentheses. So let me show you what I'm talking about. If I look at this trinomial, this quadratic, that I'm asked to solve, my first thing I want to do is make sure it equals 0, okay? Because sometimes they won't. You also always want your first number to be positive. Your leading coefficient. Otherwise, it's not going to factor right for you. Now, once we have this, we're going to put it in the box and factor it, or whatever method you use, okay? What are my signs going to look like here? Plus. Do I have a GCF?
No.
No. If I put this in the box, this is a pretty easy factor, I hope anyway, for you. What multiplies to 6x squared but adds to 5x?
Negative 1x.
Same signs, though. 2 and 3. Okay? Now up and over. Am I going too fast? I need to slow down? Okay. GCF in the first column. X. GCF here. 3. GCF here. And here. 2. Okay. X plus 3, x plus 2 equals 0. Now, I mentioned briefly yesterday, we started out with graphing. This is standard form. What does this look like to you? Intercept form, right? And it gave me the intercepts where it crossed the x-axis. Keep that in mind, because we're gonna connect that in just a minute. All right, I've got two things. Here's one thing. Here's two things that are being multiplied together to give me 0.
So that with the x.
One of them has to be 0. Either this is 0 or this is 0. Yes. Or that is 0 or both. So I'm going to have two solutions. X could be negative 3 or x could be negative 2. That's also the what of the graph. The x-intercepts, right? That's the x-intercepts. If you think about this, if you graphed y equals x squared plus 5x plus 6, if you put a 0 in for y and solve, that's finding the x-intercepts. Remember, if you plug a 0 in for one variable and solve for the other, that's the intercepts that you're finding. Isn't that neat? Y'all don't look real impressed. All right, so So algebraically, we're factoring, setting each piece to 0, and solving. I really want you to see why, though. You see why? When you multiply two things. Well, and that's another way to solve this. I could technically solve this, and let me show you. Remember that formula for me. What's that? There it is. Y equals, what was the equation?
The whole thing.
Yeah.
X squared plus 5x plus 6.
Ooh.
It's crossing at -2 and -3.
Well,
It's
that's
dipping
what graphing
down.
calculator does.
Yeah,
I need one.
yeah. I'll zoom in a little bit so you can see. Isn't that cool? Let's go down to, what's the line work? Graphing it on here?
It's a lot easier than drawing it on
Yeah.
your paper and graphing it.
All right.
Wait, so you just plugged in the X's? And it gave you that?
I didn't plug anything in. I typed this equation
So
in.
do you even have to do that?
Then why would you?
No, you do. Well,
We have a calculator to do it for us.
that's solving, because you can solve different methods. That's solving graphically. We're solving algebraically right now, but I like you to see the
But
connection between the two.
It's solving calcularity.
Solving calcularity.
Calcularity.
All right. Let's do another example. See if you got it. Let's do one that doesn't equal 0.
What do you usually get that equal to?
You make it equal 0. Tell me what to do.
Move it. Oh, wait. Yeah, you add 8 to this.
Add 8 to both sides. Why am I moving the 8 and not the 7 and 30? It needs to equal 0, but also
It's a lot easier.
I need to factor it. But what do I need to make sure about my leading coefficient or my first term? It stays positive, okay? All right, so if this had been negative here, even though there's only one term on the right, I would need to move those over because I need that to be positive. All right, 7x squared minus 30x plus 8 equals 0. Any GCF? No. What are my signs going to look like?
Negative.
Both negative. 7x squared and 8 multiplied together gives me 56. What multiplies to 56 but adds to 30? Ooh. I gotta write that one down and think about it. 18 and 2 would be, oh no, not 18, 20, what? 2 and 28? Yes. Ah.
Is the smaller number always have to go on top?
No, it doesn't matter. GCF. X GCF. 2, 4. GCF. 7x. And GCF. 2. Is that going to work? That'd be 8. That'd be, yeah. X minus 4. 7x minus 2. What do I do now? Equal them to 0. X minus 4 equals 0. This is always the easy part. Everybody always likes this because it's easy. X equals 4. 4x equals 2/7. Does that make sense? Sure. You want to graph it and see? We'll do it
So you can
anyway.
literally just plug the equation in.
7x squared minus 30x. What was it plus? 8. So I could calculate those values to make sure, which I'm not gonna do that today, because that's gonna open a whole nother can of worms, because that gets sticky.
Nah,
But if you calculated it, you would see that it's crossing at 4 2/7. Okay. Questions, comments, concerns? Do we need to do another one, or are we okay?
Can I copy this real fast?
Yes.